Hello student, how are you? I hope all of you are well and doing good. So today we are going to start welding. That is our lecture number 1. But basically it's our 11th lecture, right? Basically it is our 11th lecture, but today is the first lecture of welding. Okay, so let's start this session. My dear, in this session I'm going to cover weldability, then I'm going to cover electric arc welding, right? Then I'm going to cover electric arc welding. Now, here try to understand the weldability, okay, or welding. Try to understand the definition of welding. My dear, the definition of welding is that welding is a process by which two material, let me write down here, welding is a process, welding is what? Let me write down, let me write down welding, right? Welding. So what is welding, right? The question is, what is welding? My dear, welding is a process by which two materials, right? Welding is a process by which welding is a process by which, right, by which two material, two materials, right, two materials, usually metal are, usually metals are, right, usually metals are permanently joined, right, are permanently joined, permanently joined, right, permanently joined, okay, permanently joined, right, permanently joined, right, together by coalesces, which is induced by the combination of what? Combination of temperature, pressure and some metallurgical changes, right. The particular combination of these variable can range from, either you can give a higher temperature with no pressure, right, to a high pressure with no increase in temperature. So how can you get the joint? Joint by try to understand this point, joined together by, right, together by, right, together by what? Together by coalescence, COA, coalescence, right, coalescence. Let me write correct the spelling of coalescence. COALESCENCE, by coalescence, comma, pressure, comma, pressure, comma, pressure and what? Pressure and metallurgical conditions. Metallurgical condition. Metallurgical condition. CON, metallurgical condition. Right? Metallurgical condition. So this is it. Right? So this is the thing. Right? So this is the thing. Right? Now, my dear, there are some materials which are difficult to melt. Right? So here I am going to start the weldability. Right? The concept of what? The concept of weldability. Right? Here I'm going to start the concept of weldability. So let's try to understand the concept of weldability here. The concept of weldability, right? The concept of weldability. Weldability, right? Now, what is weldability? What is weldability? The weldability of a material will depend on the specific welding or joining process being considered, right? The weldability the weldability okay, the weldability, okay, the weldability of a of a material material will of a material of a material will depend on the specific depend on the specific on the specific on the specific welding or joining process, on the specific welding or joining process or joining process, right? Or joining process. So let me tell you a very important weldability order of some important matter, right? Weldability order of some important material. Weldability order of some important material. Important material, right? Weldability order of some important material. So let me explain this, right? Let me explain this weldability order in a very well manner. My dear, there are some material like aluminum. Maybe you have heard aluminum is least weldable. Always remember. I will tell you why the aluminum is least weldable, right? This question was asked several times. The question was asked, right, in GATE as well as various other competitive exams, right? Aluminum, aluminum is least weldable, right? If you compare copper with respect to aluminium, then copper is more weldable than aluminum, right? If you compare cast iron, then cast iron is more weldable compared to copper. Easy weld means what? Weldability is easy. If you compare mild steel, if you compare MS means what? Mild steel, it is more weldable. So the sequence of the given material in ascending order. This is the ascending order of the weldability. This is what? Ascending order of the weldability, right? Ascending order of the weldability. So this is what? This is ascending order, right? This is ascending. This is ascending order of, right? Ascending order of their weldability, of their weldability, weldability, right? Weldability. So this is a ascending order. Please remember, it is a very important, right? In various exam, this order was asked, right? This is very important. This is very, very important, right? Very, very important, right? This is very, very important in your exams, right? Now, you may be asked, so why aluminum is least weldable? How many, how many of you them can tell me that why aluminum is least weldable? Can anybody tell me why aluminum is least weldable? Yes or no? Yes. Nobody is going to tell me. Any? Can you give me any one reason that aluminum is least weldable? Okay, I will explain. I will explain. Try to understand here case of aluminum, right? Here I am going to discuss case of aluminum. This is what case of aluminum, right? Case of aluminum, right? Case of aluminum, aluminum, right? Let's discuss the case of aluminum. My dear, the number one reason, right? Number one reason that aluminum is least weldable because oxide coating on aluminum alloy, right? Oxide coating on aluminum alloy, right? Oxide coating of aluminum alloys. Now what happened, my dear? It is very simple. Let's say if there is a workpiece, this is my aluminum workpiece, right? This is what? Aluminum alloy, let's say, right? Aluminum alloy. Now on the surface of aluminum alloy, if there is a oxide, let's say this is what? Oxide, right? Let's say this is what? Oxide, right? Oxide layer. My dear, this oxide layer will resist the heat. The heat will not penetrate, right, into the aluminum because of this oxide. So if you want to do a welding of aluminum, it is necessary that you should remove the oxide, then after you can do welding. Is that point is clear? You have to, for welding, my dear, for welding, for welding, for welding, for welding, right? For welding, we have to remove, we have to remove what? We have to remove oxide layer, right? Oxide layer every time. So it is a difficult task, it is a tedious task, it is a time taking process. So that's why the weldability of aluminum get decreases. Is that clear? Because of oxide layer, because of oxide layer, heat is not able to penetrate into the workpiece. Is that clear? Is that clear? Okay. The next thing is that high thermal conductivity, right? The next point, high thermal conductivity. High thermal conductivity. Conductivity. My dear, high thermal conductivity. What is a high thermal conductivity? What is going to happen if the thermal conductivity is high? My dear, if thermal conductivity is high, then what happen now? Aluminum viscosity get decreases at high temperature, and the shape of the weld pool is not going to be maintained. Right? The shape of the weld pool is not going to be maintained. Basically, because of that, what is going to be happen? It has overall, or you can write viscosity is very low, right? You can write, instead of that, you can write that viscosity is very low. Now, can anybody tell me, sir, what happens if the viscosity is very low? My dear, if the viscosity is very low, then what is going to be happen? Let me explain you. Let's say this is what? This is the your base plate. You are doing welding, right? This is the weld pool. This is the weld pool, right? This is the weld pool, and here you can see this is the weld pool. Now, if the viscosity of the liquid metal, okay, viscosity is very low, means you are talking about when the aluminum is in liquid state. When the aluminum is in the liquid state and the viscosity is very low, then the shape of the weld pool will not able to maintain. Okay, the shape get distorted, or you can say spatter of weld pool. There will be a spatter of weld pool, my dear. There will be a spatter, there will be a spatter of weld pool, right? Spatter of weld pool. Is that point is clear? Is that point is clear? Right. Now, the next point which we are going to have to face in aluminum welding. What happened during fusion? During fusion, the aluminum would oxidize so readily. My dear, as you know, aluminum is highly reactive material. Tell me yes or no. Aluminum is highly reactive material, and this is what? This is a fusion welding where both the metal are in liquid state. What is a fusion welding? Fusion welding is that, this is what? This is a fusion welding. We are talking about fusion welding, right? In fusion welding, what is going to happen, my dear? Both the metal of the base plate, get converted into the liquid phase, and they are going to mix in the liquid phase. Are you getting my point? Both the base plate get converted into liquid, and this liquid is going to mix to each other. That is what fusion welding, right? So what is the problem, right? What is the problem when you are doing a fusion welding? Point number 3, try to understand, my dear. Aluminium is highly reactive, right? When the aluminium is in the liquid state, it readily react with the oxygen, and oxide layer get produced, okay, on the surface, right? So during fusion welding, the aluminium would oxidize so readily. During during right, let me write down here. During during welding, or during fusion welding, right? Fusion welding, during fusion welding, aluminum get readily oxidized. Get readily oxidized, right? Get readily oxidized. Is that clear? Get readily oxidized. So for that you have to use a special flux or protective inert gas, right? Protective inert gas atmosphere, so that oxidation will be prevented, right? What is the meaning is that, suppose that you are doing welding, right? Suppose that you are doing a welding here. You are doing a welding. This is a welding, right? This is a welding, and here this is the welding. Now suppose when we are doing a, okay, welding process, right? When we are doing a welding process, then there should be some protective gases. This is the protective inert gases, right? They will protect the weld pool from the atmosphere, right? They will protect the weld pool from the atmosphere. This is atmosphere, and they are not able to penetrate into the atmosphere. And how this protecting atmosphere get produced? How this protecting atmosphere get produced? Because of the flux, right? Because of what? Because of the flux. So this is a flux, my dear. See, this is what? This is the flux. See here, this is the flux. This is the flux. So this is a flux coated electrode, right? So this is the flux, this is the electrode, this is the electrode, and this is the flux coated electrode. This is flux coated electrode, right? Flux coated electrode. So this flux coated, the flux should be heavy. The flux should be heavy, right? The flux should be what? Heavy. So heavy flux coated electrode should be used here, so that it can produce a protective atmosphere. So that it can produce a protective atmosphere, my dear. This is what? This is a protective atmosphere. This is what? This is a protective protective atmosphere, right? This is what? This is protective atmosphere. This is protective atmosphere. Protective, protective, okay, atmosphere, which protect the weld pool. And basically, it is nothing that when the flux get consumed, it is when the flux get consumed, it is what? Vaporize, vaporize form of vaporize form of flux. Vaporize form of what? Flux, right? Vaporized form of flux. This is a vaporized form of what? Flux. Is that clear? This is a vaporized form of what? Flux. Is that clear? Vaporized form of flux. So the how can you overcome? How can you do the welding of aluminium? For aluminium, we are discussing the case of aluminium, right? So these are the problem. The thing is that, sir, please tell us then, by which process we can do aluminium, by which process we can do welding of aluminium. My dear, you should use what? Okay, you should use friction welding. Friction welding, you should use friction welding. You should use friction welding, right? By using a friction welding, these problem can be somehow you can overcome. And TIG welding and TIG welding, TIG, TIG welding, TIG welding. You can use the TIG welding also. TIG is what? Tungsten inert gas welding, right? Also, for aluminum, you can use AC. For aluminum, you can use AC current pulse. Okay, high frequency. AC, AC, that is a alternating current. AC, AC. Okay, current pulse. AC, current pulse. AC, current pulse. Okay, AC, current pulse, high frequency. LC current pulse, frequency, high frequency, right? High frequency you should use here, right? What happen when you use a AC current, my dear? There will be a removal of surface oxide. If you use that polarity, if you use AC polarity, then surface oxide will be removed from the base metal, right? Removal of the surface oxide from the base metal, right? Removal of the removal of the removal of the surface oxide from base metal, from base metal, from base metal, from base metal, right? Removal of the surface oxide from the base metal. So by this way you can do the welding. Is that clear? By this way you can do the welding. To changing the polarity, you can do the welding. Now let's discuss the case of cast iron. I hope you understand the case of what? Aluminium. Now I'm going to discuss the case of cast iron, right? The case of cast iron. So let me discuss the case of cast iron, my dear. Case of cast iron, right? Case of cast iron. Cast iron. Now, how many of you them can explain the case of cast iron? Why we face the problem? Okay, why we face the problem in welding of what? Cast iron. My dear, cast iron is more difficult to weld, right? Cast iron is more difficult to weld because of its high carbon content. Cast iron is more difficult to weld, right? Cast iron is more difficult to weld. Cast iron is more difficult to weld. So let me write down. Cast iron is more difficult to weld because of its high carbon content, right? Cast iron is more difficult to weld. Okay, it is more difficult to weld. Why? It is more difficult to weld because of its high carbon content. Because of its high carbon content. Right. Now what happened? What happened? What happened if the carbon content is high? My dear, if the carbon content is high, then brittleness will become okay in the weld pool. Why? Because of the high carbon content. Now, because of the high carbon content, poor fusion will occur. Poor fusion in the weld pool. If the fusion is not proper, then the joint is brittle. Right. So, because of high carbon content and brittleness, because of high carbon content and brittleness and brittle and brittleness, right? So poor joint quality you will get. Also the second point, this is the first point in the cast iron. Let me write down the second point also. Let me write down here the second point, right? Let me write down the second point here. So here, second point is that, see, second point, my dear, massive carbon deposit, massive carbon deposits have a tendency to form in the area of adjacent to the weld. Basically, what is going to be happen? Let me tell you, right? Let me tell you here, what is going to be happen here. If the welding is going to be happen now, if the welding is going to be happen, this is the weld pool, right? This is a base plate, and this is the welding, right? This is the welding, right? This is the welding, right? This is the welding which we are doing now. During welding, what happened now? When you are going to do a welding of cast iron, then the carbon is going to be deposit at the at the at the weld pool, at the near about the weld pool, at the near about the weld pool. Why? Because of pure fusion. So massive carbon deposits have a tendency to form in the area adjacent to the weld pool, adjacent to the weld, and high carbon martensite tends to form in the heat affected zone, right? In the heat affected zone. As you know, this is what? This is a heat affected zone. As you know, this is what? Heat affected zone. So in the heat affected zone, in the zone, heat affected zone, the high carbon content martensite is going to be formed. Because of that, the brittleness will become here, right? And when you apply the load, the joint may get break. When you apply the load, the joint may get break, right? So let me write down here the reason. Let me write down here the reason, right? What is actual line? Massive carbon deposit have a tendency, massive carbon, massive carbon, right? Massive carbon deposit, massive carbon deposit, massive carbon deposits, okay, massive carbon deposits have a tendency to form, have a tendency, have a tendency to form, to form, have a tendency to form in the areas, in the areas, which areas? Adjacent to the weld. In the area adjacent, adjacent to the weld, to the weld, adjacent to the weld, right? And because of what? Because of that, what happened? High carbon martensite tends to form, right? High carbon, high carbon martensites tends to form. High carbon martensite tends to form. Okay, and and high carbon high carbon martensite tends to form. Martensite tends to form, right? High carbon martensite tends to form. And because of that, what happened? A crack may be developed spontaneously while you are doing a welding, or while when you are applying the load. So this is a case of what? This is a case of your aluminum. So I hope this point is crystal clear, right? This point is crystal clear. So the problem is that, sir, if that much problem will come in the case of cast iron, then sir, what we will do? My dear, if these problem will come in the cast iron, then the solution is very simple. And here I'm going to tell you the solution, right? And here I'm going to tell you the solution. Now try to understand the solution here. Try to understand the solution, right? Try to understand the solution, right? Try to understand the solution. Try to understand the solution. Try to understand the solution. Now the solution is very simple. Right now the solution is very simple. Cast iron can be joined by the oxyacetylene brazing. Right? Cast iron can be joined, cast iron, right, can be joined by the oxy, okay, by the oxy, oxyacetylene, right? Oxyacetylene, right? Oxyacetylene freezing, right? Oxyacetylene freezing process. Oxyacetylene freezing. Is that clear? Is that clear? And shielded metal arc welding and shielded shielded metal arc welding. Metal arc welding. Metal arc welding you can use here, right? You can use here. This is the tip number one. Now, the high carbon martensite, my dear, the high carbon martensite which form in a heat affected zone, because of what? Because of the cooling rate, because of the high cooling rate. So it is necessary that you should maintain the cooling rate of the weld pool. So for that, what you should do, some cases preheating is required. Means before welding, you should heat the base plate. You should heat the base plate before welding. You should heat the base plate so that whatever the heat in the weld pool will not loss in the base plate. In the base plate. So some cases preheating is required. So some cases, right? Some cases preheating is not required. Some cases preheating preheating is required, right? Is required. Now preheating means you have to heat the base plate. You please be aware, you don't have to melt the base plate, you just have to heat the base plate, like up to the temperature of what? Up to the temperature of 100 degrees Celsius to 150 degree Celsius. So this must be the required temperature. If it is required, basically we have to control the cooling rate, right? Why we are doing to control the cooling rate, right? It help to control the cooling rate, right? Basically this process, this thing will help, okay, to control to control the cooling rate, to control the cooling rate, to control the cooling rate. Basically you have to control the cooling rate, right? Now now if suppose, because when the cooling rate get controlled, when the cooling rate get controlled, here you have seen that in in heat affected zone, martensite get formed because of improper cooling rate. When the cooling rate can control, then the formation of martensite, please see, then the formation of martensite get reduces. Formation of martensite gets reduces. If the formation of martensite get reduces, then what happen? Joint is good, right? Joint get good. So to control the cooling rate, it reduces the, basically it reduces, it reduces what? It reduces this sufficiently to avoid, it reduces this sufficiently, sufficiently, sufficiently to what? Sufficiently to avoid martensite formation. To avoid, to avoid martensite, martensite formation, right? Martensite formation. Am I clear? This is the thing. Sometime, if it require, then do post heating. Post heating means what? After welding. Post heating means what? After welding, you can heat the base plate, heat the joint and base plate, right? This is a post heating. But remember that post heating at a higher temperature, at a higher temperature to temper the martensite, right, is required. So if it is required, then do the post heating as well as, okay. If it is required, if it is required, then do the post heating as well, my dear. Okay. So here I'm going to write. Please listen. So here post heating at higher temperature, post heating at higher temperature, at higher temperature, okay, at higher temperature, post heating at higher temperature, right? Post heating at higher temperature to temper the martensite, to temper, to temper the martensite, martensite, to temper the martensite, right? To temper the martensite required, to temper the martensite required. So somehow you can manage the formation of martensite. The basic problem in cast iron is that poor fusion. Always remember, the basic problem in in the cast iron is what? Poor fusion. Poor fusion. Right? This is the problem in cast iron. This is the main problem in cast iron. This is the main problem, main problem. Right? Main problem. Because of that, what happened? The joint get brittle, right? So you have to manage this one. If you manage this one, then you will get the good joint of what? Cast iron. Is that clear? Now now I'm going to discuss the case of stainless steel, my dear. I hope till now the thing is clear. Till now you understood this order. Please remember this order: aluminum, copper, cast iron, mild steel. Here the important material. Okay, for exam purposes, aluminum, cast iron, and mild steel. I have discussed the aluminum. I have discussed the cast iron. Now I'm going to discuss the mild steel. Right. Now I'm going to discuss the mild steel. So let's start the case of mild steel here. Let's start the case of mild steel here, right? Let's start the case of mild steel. Let's start the case of mild steel. See the case of mild steel, please. Yes. See here. See here. My dear, case of stainless steel. Here I'm going to discuss case of stainless steel. Stainless steel, right? Case of stainless. My dear, stainless steel is difficult to weld. Difficult metal to weld because it contains both nickel and chromium, as you know. Stainless steel here, stainless steel is stainless steel is difficult to weld, difficult to weld, right? Difficult to weld because it contain, it contain what? It contain both nickel and chromium. It contain both nickel and chromium. Pro, right? When you do the welding of stainless steel, the nickel and chromium, right, remove from the weld zone, right? Okay. So the best method for welding stainless steel is TIG welding, right? The best method. Okay, the best method for welding, the best method for welding, for welding, the best method, okay, for welding stainless steel is, for welding stainless steel is, steel is TIG, tungsten inert gas welding, TIG welding, right? This is the best method, right? This is the best method to do the welding, right? This is the best method. So I hope you understand this thing very well. Now let's move to the, okay, next point. Now, how can you, how can you avoid, how can you avoid the removal of nickel and chromium, right? How can you avoid the removal of nickel and chromium. My dear, the best thing is that electric arc is also preferred for welding stainless steel. The You should have a heavily coated welding rod. Okay, a heavily coated welding rod which produce a shielding arc. Okay, a heavily coated. You should use a a heavily coated, heavily coated, right? A heavily coated welding rod. A heavily coated welding rod should be used, right? A heavily coated welding rod should be used, right? In the operation, right? Also, you should use a low arc current. Low arc current. If the arc current is low, and along with that, you have to use a fast travel speed. If the arc current is low and fast travel speed is there, then what happens? Less heat per unit length will go into the base plate. Less heat per unit length will go. Less means, you can say optimum heat will go into the base plate per unit length, so that so that carbide precipitation. The meaning of carbide precipitation is what? Chromium and carbon get react to each other if you give the high heat to the base plate, and it form the carbide precipitation. Means you lost the carbon as well as chromium from the mild steel, right? So you should use what? Using a low arc current setting. Using using a low arc current setting, right? A low arc current setting. You should use a low arc current setting, my dear, right? With faster travel speed. With faster travel speed. With faster travel speed, right? With faster travel speed. Because of that, you can avoid the precipitation of what? Carbide, right? With faster travel speed is important. So faster travel speed is important. Is important, right? Faster travel speed is what? Is important when welding stainless steel. When welding when welding stainless steel. When welding stainless steel, right? Because some stainless steels are because because some stainless steels are because right because some stainless steels, okay, are subjected subjected to subjected to carbide precipitation. Precipitation, right? Precipitation. I hope the point is crystal clear to you people, right? I hope the point is crystal clear. Now, let me enter into the concept of electric arc welding. Here, now I'm going to start electric arc welding, my dear, right? Electric arc welding. So let's start electric arc welding. Okay, electric arc welding. So let's start electric arc welding. Electric arc welding. Electric arc welding, right? My dear, in electric arc welding, basically what we do, try to understand. The arc is generated between cathode and anode when they are touched to stabilize the flow of current and then separated by a small distance. Are you getting my point? Now try to understand. There will be a electrode or there will be a workpiece, right? This is a workpiece and this is the electrode, right? Now when you touch the electrode, okay, when you touch the electrode, basically when you touch the electrode there will be some polarity. Let me write down. The polarity is what? This is the negative generally and this is the positive, right? So when you touch the electrode, then what happen? The electron will flow, right? And then you separate it by a small distance. When you separated this by a small distance, right? Let's say it is L. Then what happened? The arc get produces in between the gap. So here L is what, my dear? Here L is the arc length, right? Arc length. Here L is what? Arc length. Generally it will be in mm, very small value will be there. So what is going to be happen? An arc is stabilized between cathode and anode. So I'm going to write an arc is going to be stabilized in between cathode and anode, right? An arc is stabilized in between cathode and anode, right? An arc is going to be stabilized in between cathode and anode, right? So let me write down here, here, an arc is generated, an arc is generated, okay? An arc is generated between cathode and anode, between cathode and anode, between cathode and anode, right? Between cathode and anode. When they are touched to stabilize, when they are, when they are touched to stabilize, right? When they are touched to stabilize what? Stabilize the flow of current, the flow of current, the flow of current, right? The flow of current, the flow of current, right? The flow of current, and then separated by a small distance, and then separated by separated by a small distance, okay, separated by a small distance, right? So this is what? This is the cathode here. This is cathode, right? Negatively charged is cathode, positively charged is what? Anode, right? So when the electrode is cathode and the workpiece is anode, then my dear, at the anode 65 or 70% or 70% heat is generated at what? At the anode, right? 75% heat is generated at the anode and 30% heat is generated at the cathode. My dear, if the workpiece is positive, if the workpiece is positive and electrode is negative, that polarity is known as what? Straight polarity, right? That polarity is known as what? Straight polarity. So let me write down, okay, if a DC current is used, okay, if if DC current, if DC is used, right? If direct current is used, okay, and the work is positive, and the work is, and the work is positive, and the work is what? Positive. Work is positive means what? Anode, right? The condition is known as, that condition is known as straight polarity, SSTRAI, straight polarity, straight polarity, straight polarity, direct current, direct current, okay, straight polarity, direct current, okay, straight polarity, direct current, might. This is the, okay, this is the thing, right? This is the thing, straight polarity, direct current, right? Straight polarity, direct current. I hope you understand this thing. Now, in short, we will write SPDC. But suppose that if DC is used, if DC is used and the work is negative, if the work is negative, then it is what? Reverse polarity, reverse polarity, right? Reverse polarity, direct current, direct current, right? In short, we can write RPDC, RPDC. My dear, when there is a RPDC now, then the heat distribution will be reverse. The heat distribution will be reverse. What is the heat distribution in that case? Let me draw here. This is your electrode and this is your workpiece. Let's say here I'm talking about this one. Okay, plus and negative. Here tool is what? Positive. Tool is what? Anode. Tool is what? Anode. And this is what? Cathode. Right? This is what? Cathode. Now, in that case, what is going to happen? This polarity is known as what? RPDC. In RPDC, now 70% heat is generated at the anode and 30% heat is generated at the workpiece during welding. Okay, during welding. I hope this point is crystal clear to everybody, right? I hope this case is crystal clear to everybody, right? Now, somebody asked to me, sir, which polarity we used in our welding? My dear, SPDC condition is preferred. Generally, SPDC condition are preferred, but in some special case, we use the RPDC. In some special case, we use the RPDC, in which case overhead welding. When you are doing a overhead welding, in that case, we prefer what? In that case, we prefer reverse polarity direct current. Is that point is clear? So, generally, here let me write down a point. So, SPDC condition are preferred, right? SPDC, SPDC, straight polarity direct current conditions are preferred. Condition are preferred, right? Preferred. Okay. Second, where when we use the RPDC, when we use the RPDC, RPDC condition we use in overhead welding. We use in overhead welding, right? Overhead welding, overhead welding we use in overhead welding. So please remember this point. Okay, please keep this point in your mind. Now, either you are do either you will do this, either you will do SPDC polarity, either will you do RPDC polarity. Here the arc length should be constant. Here the arc length should be constant throughout the welding. For a stable arc, the gap should be maintained, right? For a stable arc, let me write down where I should write down. I'm going to write down here. I'm going to write down here, right? For a stable arc, 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 okay, for a stable arc, the gap should be maintained. The gap should be maintained. The gap should be maintained, right? The gap should be, is that clear? So this is an important thing. Please remember this point. The gap should be maintained, right, during the welding. Now, one more point I'm going to write here. I'm going to write the table, right? I'm going to write the table. Okay. So here, please see here in this table, I'm going to mention the polarity, right? Electrode polarity, electrode polarity, polarity, right? Here I'm going to write the electrode polarity. Electrode polarity means electrode is positive or negative. What is that? Right. Now, the next column, the next thing is that I'm going to draw the figure. This is the electrode, my dear, right? This is the workpiece, right? Similarly, this is the workpiece, right? And here you can see this is what? This is the electrode, right? This is again the electrode, right? Here this is again your workpiece, right? This is again the workpiece. Now in that case, if the workpiece is what? Positive, and the sorry, if the tool is what? If the tool is negative and the workpiece is what? Positive. If the tool is positive, the workpiece is negative, right? So my dear, when the electrode polarity is negative, when the electrode polarity is negative. Second, when the electrode polarity is what? Positive. Now, the third case, here you can see we are using AC, means polarity get changes. Okay, polarity get changes. Okay, this is the AC, right? This is the AC. In this polarity, let's say in this polarity here, please try to understand here. Please try to understand in this cycle, the polarity of the tool is what? The polarity, the electrode is negative and the workpiece is what? Positive. The next half cycle, the electrode is positive and the workpiece is negative. So the polarity keep changing. So this is a AC polarity, right? So this is a AC polarity. Now, so this is the case. Now, in which case the oxide cleaning will take place, right? In which case the oxide cleaning will take place. First, second, and this is third, right? This is third. Please see. Here, my dear, listen carefully. Here I'm going to write oxide cleaning, right? Here I'm going to write oxide cleaning. Oxide cleaning, right? Oxide cleaning, right? Oxide cleaning action means on the surface, oxide is going to remove or not. When you are using SPDC condition, this is what? SPDC, right? And this is what? RPDC, and this is what? AC polarity. So when you are using SPDC condition, there will be no removal of the oxide from the surface. So no oxide cleaning. When you are doing a reverse polarity, then from the surface, oxide cleaning will be there, right? And when there is a AC polarity, then in that polarity, my dear, in when the electrode is positive and the workpiece is negative, in that polarity, the oxide will remove. So yes, but when once even half cycle, once every half cycle, okay, so oxide get removed. Yes, when when once every half cycle, yes, once every half cycle, right? Once every half cycle. Is that clear? Now let me discuss, let me write down the heat balance equation. Heat balance in the arc. Heat balance in the arc, right? Heat balance, in arc welding, right? My dear, as you know, when the tool is negative, then and when the workpiece is positive, so 70% heat is generated at the work. So here you can write that 70% at work and 30% at electrode, right? When the polarity get changed, then 30% at work, right? And 70% at electrode, right? So that much heat get produced on the respective surface. But here you have seen the polarity get changes in every cycle. So 50% heat, 50% heat at work and 50% heat at electrode, right? At electrode, right? Now you can see that if the 70% heat produces at the workpiece, then the well pooled depth is what? Large. Okay, well pooled depth is large. Okay, and width is what? Width is less. And when the polarity is RPDC, then weld pool depth is less, and the width is what? Width of the weld pool is wide. And when the AC polarity, then there will be a medium height of the weld pool, okay, and width is what? Medium. So penetration, let me write down the next point is that penetration. Penetration, right? Penetration, right? So here deep and narrow, here deep and narrow, right? Deep and narrow, right? The depth of the weld pool is deep and the width is narrow, right? The depth of the weld pool is what? Shallow, okay, shallow, and the width of the weld pool is wide, right? Wide, right? And when there is a AC polarity, then the depth and width is medium. Is what? Is So this is about the arc welding. I hope you understand the concept of arc welding in a very well manner, right? So thank you very much for watching this video. We are going to meet tomorrow and we are going to discuss the welding. Okay, our discussion will be continue in the next session, right?